Here's the other investigation that's referred to from the page 3 problem set. It's investigation 3. You need another manipulative to do this one. It's similar to the last investigation. The difference between the last investigation and this one is the last investigation didn't really tell you what function you were finding the instantaneous velocity of, but obviously it was looked like a quadratic, and this one is a quadratic. So we're going to do the same thing now, except we're going to do it with quadratic y equals x squared, and we're going to show that taking a chord between 2 points, such as these two, and getting them closer and closer and closer is going to converge them to a certain number, which is going to be the slope of the tangent line, or the gradient of the tangent line at that point. So we're going to take this parabola, y equals x squared, and we're going to draw a chord from 1, 1 to 3, 9, for example. And the first point we're going to do is actually 5, 25, which isn't even on this drawing. But if we were going to find the slope from between 1, 1 and 5, 25, how would we do that? Well, we'd subtract the y's, which is 25 minus 1, and then we'd put that over the subtracted x's, which would be 5 minus 1. And the result would be 24 divided by 4, right, which would be 6. And I just wrote that off the screen. 6, right? And what do you know? There's 6 right there, right? So we've done the first one by hand, but we're going to do the other ones with the manipulative. It's quite a bit easier. So first we're going to do the first point 1, 1, and we're going to compare it with 3, 9. So the second point is going to be 3, 9. So let's take the blue point and we'll put on 3, 9. Oh, I already did that. What's the slope? Slope's 4. Now I'm going to do it between 1, 1 and 2, 4. And this is a pretty cool manipulative. All I have to do is type in 2, and it's going to go there. Okay. The slope is 3. And that's 2, 2, 4. What about if I put the blue point on 1.15? Oops, I'm sorry, it's 1.15, not 1.15. So that would, the point would be 1.5, comma, 2.25, and the slope is going to be 2.5. Do you see how we're converging to a number here? We went from 6 to 4 to 3, 2.5. What if we made the blue point 1.1? Now it's going to be 2.1. What if we made it 1.01? Now it's going to be so close we can't even hardly see it, right? Let's go to, yeah, okay. So now we're going to do 1.01. Oops. I don't think it likes that. 1.1. Okay, now we're gonna zoom it in. So now we're gonna go to 1.01. 1.01. So if we put it on 1.01, oh, very close. Okay, there we go. 2.09. Basically, it's like 2.1, right? 2.09. Hardly changed. Now about 1.001. I don't even think I can do that. .01. Oh, no, too close. 1 undefined. What's the y undefined? Because it's 0 divided by 0. 1.003. Look, it's already at 2. Okay? So, I mean, it's basically, I can't really get any closer than that. My finger is not steady enough. Okay? So, but basically you can see that we're converging to a slope of 2, right? Even though it's probably 2.0001, it shows 2.0 already. So, as we go down the table, as we get our blue point closer and closer to our green point, we're converging to a slope which is going to be the derivative at that point. It's going to be the gradient of the tangent at that point. It's converging to a number which is 2. So even though if you took the slope by drawing a little triangle, you get 0 divided by 0, you can see with the manipulative that as you get closer and closer, you don't get an undefined number. You actually get a number 2. Okay? So let's answer the questions now. Let's see, 1a. What's 1a? Show that the chord has gradient x squared minus 1 divided by x minus 1. Yeah, we did that, right? We did that up here with 24 divided by 4. We could do that by saying, oh yeah, like the y2 minus y1 divided by x2 minus x1 is equal to, and then the y2 is x squared, the y1 is 1, the x2 is x, and the y2 is 1, right? Because the second point is x and x squared. Okay, and then let's see, 1c. Comment on the gradient AB as x gets closer to 2. It seems to be approaching 2. And number 4, what do you suspect is the gradient of the tangent at A? 2. Okay, so that was not too bad, right? It's similar to the last one, except this time we're actually looking at the function's equation x squared.